We are EPRIMAG, and our project is design of a proof of concept non-destructive testing device using the metal magnetic memory method. This project is sponsored by the Electric Power Research Institute, or EPRI.
The motivation for this project is to investigate the viability of a non-destructive testing technique, the metal magnetic memory method, which involves the passive detection of magnetic field memory projected from a ferromagnetic substance. The objective for this project is to design and build a proof of concept device that would be able to passively detect magnetic intensity in 3 orthogonal directions and calculate the spatial derivative of a magnetic field in 1 dimension.
The device being designed needed to satisfy 4 main specifications. It needed to measure the magnetic field intensity in 3 orthogonal directions, track position in 1 dimension, display scanner readings, and compute the spatial derivative of the magnetic field. The design of the device was created around a central microcontroller, which communicates with a 3-axis magnetic sensor and a positional encoder. The microcontroller then relays the information to a computer via USB, where it is displayed in the user interface. Here's the device construction, which consists of a custom printed circuit board and 3D printed housing to contain the various components.
Verify the derivative was getting calculated correctly. The microcontroller passed a sine wave and the interface calculation was compared to the theoretical calculation. These values were very close. To verify the user interface was displaying correctly, a waveform generator was connected to the microcontroller, and the waveform generator would pass different signals, and these signals would display in the user interface. The scanner must be able to accurately read the magnetic field, so a known magnetic field was generated by running a current through a wire. The change in the magnetic field can be observed in the data below.
There are some planned activities for the remainder of the semester. We must verify the distance measurement and verification testing of the positional encoder. Samples were also received from EPRI, where stress concentration zones were identified, and this may be used for testing of the metal magnetic memory method. And in conclusion, some more testing needs to be done on the positional encoder to meet the requirements of the project. And there are concerns about the effectiveness of the device in reading variation in the magnetic field due to small magnitudes. And the budget for this project was $3,000, and the team spent a fraction of that.